So yeah, my name is Roisin McArdle. The way that I'm hoping to run this session today, a lot of it is going to be me talking, but I would like you to make use of the chat feature. At different points, I'll pause and have a look and see and if there's any questions or comments that I can kind of pick up on. So just to introduce myself again there, yeah, my name's Roisin McArdle and I worked in the primary sector for about 5 years, taught in a few different councils around Glasgow. And I started off at primary 7, but over the course of those years taught across all the levels. The last class that I had in primary was a primary 2 class. And while I was teaching in primary 2, a job was advertised for a principal teacher of numeracy. And it was 3 Glasgow schools, Hill Park, Ross Hall and St Paul's. And it was one of the ways they used their PEF money to have a principal teacher of numeracy and a principal teacher of literacy. So I kind of put myself forward for that, not really thinking I would get it, to be honest. I'd only been teaching a short amount of time, and I've got 4 sisters who are all secondary teachers, and it was one of them that said, no, I think you'll quite like the secondary sector. Up until that stage, I'd always thought of myself as a primary teacher. And then when I moved into that role for the 2 years that I did that, I still referred to myself as a primary teacher. I introduced myself in everything as I'm a primary teacher or primary specialist. And it was only at the end of that 2 years that when I applied for my GTC registration in secondary maths, that I adopted the role of what I would call a proper maths teacher. And I've been doing this job for a year and a half now at St Andrews Academy. So the sort of things that I'm going to talk to you about today are, it's not that I've done loads of research on particular things. It's more that I have tried some of these things out and I think they work for me. And hopefully, someone's unmuted just now. So for the majority of this session, I'm happy for you to stay with cameras off and muted, whatever. At the end, if there's any particular questions, if anyone's wanting the last 5 minutes or so, hopefully, if I leave myself enough time, I'm happy for questions to come verbally at that stage. So the topic that I'm talking about today, fractions, is one that in my experience has, pupils have a lot of misconceptions around the topic of fractions. It's a topic that you think they know bits and then suddenly they come up with an answer that doesn't make any mathematical sense because they've just taken a process that they know from somewhere else and put it into the topic of fractions. So I did some very low-level research before starting this, and I went on to Google Images and I just typed in fractions. And here are some of the things that come up in Google Images for fractions. So what I would love from you just now in the chat is just, do you have an opinion of any of these things? Positive, negative, or whatever. What is your opinion on some of these pictures that we've got in here? Okay, so lots of opinions, positive and negative, coming in here, and some of you have kind of hit the nail on the head with some of these things. So pizzas seem to be one that people have an opinion of, and it's not always a positive opinion. This idea of using pizzas as a tool for representing fractions, I can fully appreciate the negative association with that because sometimes we end up with only pizzas being used as an example. However, when I think about my 4-year-old nephew who has not started school yet, but he's beginning to understand, have an awareness of this word half. And the only time that he ever has something that is halved, as if he's half, if something is cut in half with his sister. When we were younger, we used to, if we were sharing something between me and a sister, we would have one sister gets to half it and the other gets to choose, because you would always want to choose the bigger half. And of course, that's not mathematically accurate, and that then can lead to discussions on the maths behind that. But quite a few of you are looking at this and saying, we need all representations. And what I'm trying to get across today is that we need a range of representations. When I look at part H there, that's just the way fractions can be written. I'm an absolute stickler for, when pupils are writing fractions, that they write the numerator and a horizontal line and then the denominator, so that you know which one is the numerator and which one is the denominator. So I would be asking them to write it the way that it's written in part D or part E. And when it's written like this in jotters, I would encourage them to write it in a proper format. However, pupils need to also be aware that this is how it's written, so that if they see it that way, that they can understand it. So there's loads of ideas for teaching and whatever else that can come from these. I'm just putting this here as a bit of a prompt for thinking about what are your opinions on some of these ways of teaching fractions. So what I'm hoping to talk a bit about today is equivalence. And within equivalence, I'm going to be speaking about things that are not equal, so comparing fractions, mixed numbers, improper fractions, and fraction of an amount. If I get through them all in time, we'll see how we get on. I probably won't have time to go fully into fraction of an amount, but it's a topic I've spoken about a bit before, and I'm assuming that these slides will be available after if anyone's wanting to look through them at their leisure. So in terms of equivalence, when you look at the experiences and outcomes for fractions, and I'm saying this in terms of those of you who are teaching in Scotland will recognise these, the idea of equivalence comes in quite early. And when you look at the benchmarks, we're encouraged to teach pupils using pictorial representations and other models to understand simple equivalence. For example, 1/2, 2/4, and 3/6. And I fully agree with that. However, it's not until third level that we start using this word of adding and subtracting fractions. Now, by third level, it's when changing a denominator. But one of the things that I think, in my experience, is missed and not always fully understood is when we talk about 2/4 or 3/6, what do we mean by that? Because if pupils don't understand what we mean by 2/4, if they don't understand that that's two of these things called 1/4, then there's some sort of a misconception that could very easily arise there. So thinking about 1/5 and 1/5, and I'm sure that many of you have been in a position where you're teaching fractions and you're teaching adding with the same denominator, a common denominator, and 1/5 and 1/5, we get an answer of 2/10. Now, using the fraction tiles can make that can make it very clear what the answer is. But what I would urge you to do, if you don't already, is just ensure that pupils know that. So when they're writing 1/5 equals 2/10, that they understand that 2/10 is 1/10 add 1/10. And I know certainly in my planner at school, adding fractions with the same denominator comes on much later. We would be doing that much later after they've done equivalence. And if pupils don't understand that part of it, there's a potential for mislearning there. One of the pictures that I showed here at the fraction wall is obviously something that is hugely worthwhile in mathematics. One of the issues with the fraction wall and fraction tiles, not an issue, but something that just has to be noticed, is that there are certain fractions missing. So in this one here, we don't have 1/7, we don't have 1/9, we don't have 1/11. And there is like that can cause a misconception to pupils where they don't think those exist, or they think that this is an exhaustive list of all fractions. So a fraction wall up on the wall definitely has benefit. Like there's a use to it being there, but if that is the only way that you share what fractions look like, you're limiting some of the understanding that pupils can get. I would much prefer to be able to show pupils fraction walls, fraction tiles, sorry, in real life. So one of the websites that I'm going to refer to a lot through this session is the MathSpot website. And if any of you are not familiar with MathSpot, I would suggest that you go onto it at your earliest convenience. It is a website. The manipulative section of this website is brilliant. There is no substitute for the actual concrete resources and moving them around. However, this is a very close second to that, and it's something that I've been using a lot more now with online learning. So this fraction wall allows you to move the fractions around, etc., and play around with them and check the size of them. And it's quite nice because they kind of slot into place, so that if you're teaching something about equivalence, you can use that. One of the things that I hear from colleagues quite a lot is that when pupils get to secondary school, they don't want to, or some colleagues may even argue they don't need to use concrete resources. And I think they do need to use them. However, I have been met with resistance from pupils before. So there are times that I will bring this resource out with a first year class and have one or two pupils who think, I don't need that, that's for primary school. To be honest, it's not actually as often as you would think. They do still enjoy playing around with them. So one of the ways that I try to overcome this is by forcing them to use the fraction tiles to be able to work something out. So for example, using a question like, which is larger? And we say something like 2/8 or 6/8. And of course, here I should be clarifying of one, but 2/8 or 6/8, which is larger? And I might ask this question with many whiteboards, and almost all the class will get that one correct. They're quite happy with that idea. What about if it's 1/5 or 1/8? And at this stage, you might pick one or two pupils who have that misconception. I'm talking about when I'm working with pupils in secondary now. But there might be that misconception here that 8 is a larger number, therefore it's a larger fraction. And of course, we're talking about of 1. But there are times, on the most part, when working with those sort of ages, that misconception can be dealt with pretty quickly. After that, I would consider something like this, 3/5 or 3/8. And we always compare fractions with a common denominator, but we can just compare them with a common numerator. That is another way to compare these fractions. And if pupils understand comparing fractions, they should understand this idea, which is larger, 3/5 or 3/8. If there is something common between the two of them, then we can compare them with ease. Then on to this one, 3/5 or 5/8. And if I ask this to a class full of first years with whiteboards, my most common reaction or the most common response is mixed. Some will go for 3/8, some will go for 5/8. One or two will start to do some working out in terms of equivalence. But on the most part, this is a sort of question I can ask a class of that level and can then ask them to prove it, and if they know about equivalence and etc., then they can prove it. But at that stage, a lot of them won't have an idea of how to do this confidently, the pupils I've worked with. So we can look at the fraction wall, and when you do that, you can start to see which one is larger. However, when you do it with the fraction tiles themselves, it's then very clear. I choose this one here, 3/5 and 5/8, because when you do them with the fraction tiles, they look very similar in size. So you start getting pupils saying something like, oh, they're nearly the same. And then we can have that conversation of, well, what do we mean by equivalence? They're either the same or they're not. They are equal or they are not. And right now, those two fractions there are not equal. And one thing I would just urge here, this is my personal opinion again, but there is great benefit to the process of children making their own fraction tiles, for children to recognise that a quarter is half of a half, to recognise or to fully see the size of 1/3 by splitting a bit of paper up into thirds. I completely agree with that. However, I would advise against pupils then using those fraction tiles when creating calculations, because there can be misconceptions there. If they've not created fractions that are absolutely the same size, if they've created fifths that are not all actually fifths, then we run the risk of moving into more misconceptions. And even if it's a teacher that has made these tiles and printed and laminated them, when you cut them out, if the printer is not absolutely perfectly synced, these two fractions can end up looking like the same size. So I know that there's not an option right now, we're not even in school, to be able to use the fraction tiles, but the use of, I would suggest using the website over paper ones in this sort of situation, just to ensure that pupils are not developing any more misconceptions. So looking at equivalent fractions here, one of the ways, those of you that are from Glasgow, if you've been doing the Glasgow Counts training, one of the ways that they suggest it is through using the bar model. So here we've got 3/5, and I can represent this 3/5 in this same way, or I can start splitting it up to show the equivalence. So here we have, this is still 3/5. I've not changed the size of any of this. But by splitting it in half, we can now see that there are 6 parts out of 10. So this visually shows that there are 3/5, which is the same as 6 parts out of 10. We could split it in a different way to show that 3/5 is the same as 9 parts out of 15. So some of those ways of showing equivalence with the bar model, I think are hugely worthwhile, but what I would encourage is the step before that, if you can, using the fraction tiles. One of the ways I would introduce it using fraction tiles is by using a statement or an open-ended question like find fractions that are equivalent. And when pupils are doing that task, they might come up with things like this. And I would be encouraging at this stage for pupils to annotate on a whiteboard so that they're getting used to what the abstract understanding is, and what that looks like in the abstract. So 1/4 and 2/8 is equal to 2/8, or 2/3 is equal to 4/6, and actually writing that down. More often than not, when I'm doing my class, a lesson like this, I start having pupils, the question that they quite often ask here is, can I use different colours? So they don't use the mathematical language of, are we allowed to use different fractions and create fraction calculations? They say, can I use different colours? And my answer to that would be yes. But I would be interested to hear what other questions you would ask pupils as they are doing this task. So if you've got any ideas on that, you can put it into the chat as well. Yeah, so loads of different ideas about this, about the last sort of things we were speaking about there. So I'm going to offer an alternative idea here that I used with my second year class. Now, this changes the way that I would normally have done a bar model, but I was doing this with a class who have already understood a good bit about fractions. They've already understood equivalence. And when we looked at the idea of equivalence again, I was conscious that there was pupils that had quite a good understanding of equivalence already. So we created bar models like this, and somebody in the chat there mentioned the language out of, and this is exactly where I would use this language in identifying that this is 1 part out of 5. Now that's a different way of thinking about fractions, because often we would do a 1 along the top and split up into 5 parts to show that each of those parts is 1/5, and think of it as 1 divided by 5. But this bar model here doesn't actually show me 1 divided by 5. It shows me 1 part out of 5. And that's a different understanding of fractions, and not necessarily one that in the past I would have explicitly taught as clearly as I think I would need to. So 1 part out of 5, and you can look at equivalence in this sense and create equivalent fractions pretty quickly from this. So 1 part out of 5 is the same as 2 parts out of how many? And pupils straight away said, well, it's the same as 2 parts out of 10. They can see that looking at it. So 1 part out of 5 is the same as 2 parts out of 10. 1 out of 5 is the same as 2 out of 10. 1/5 is equal to 2/10. And then we can move on to, well, 1/5 is equal to how many out of 35? And I'm not saying multiply by this, divide by this. I'm not saying any of that. I'm just saying, what would it be the same as? And they can say, just visually by looking at it, it's the same as 7 out of 35. So this is a task I did pre-lockdown with my second years, and I changed it into an open-ended task. And I said things like, show me fractions that are equivalent to, and then I gave them a fraction, or I opened it again and I said, show me fractions that are equivalent. And from that, I ended up with pupils that were having denominators of like 1035 and making up their own calculations. Since the start of November, that second year class that I'm speaking about, because our school had so many absences from close contacts, it was decided that instead of being in their ability classes for maths, they were going to change to mixed ability. So this sort of task for me, teaching a mixed ability class in second year about equivalence, I knew that there was pupils in there that needed a wee bit of reinforcement of it. And this wasn't the first task we did on fractions, not by a long shot. But a task like this one here let me open it to those pupils that wanted to challenge themselves a little bit more, basically. And it then led to some really interesting ideas. And this one here is what one of the pupils came up with. So it hasn't actually shaded it there, but if that was 1 part out of 4 is the same as how many parts out of 2. And this one actually then made me question, what do we constitute as a fraction? Is 0.5 over 2 a fraction? And that was the way that he wrote it down in his jotter. He didn't write 1/2 out of 2. He didn't write it in that way, which would not have been, I knew that one, as a class, we would have agreed that that would not be allowed. So 0.5 over 2, and I opened it up to the class and I said, is this allowed? And there was kind of mixed responses. And then in my own head, I kind of thought, is this allowed? And when I'm saying, is it allowed, is it permitted? I'm thinking, well, in mathematics, we quite often see things written with a decimal number on as a numerator and a whole number in the denominator, or the other way around, because it can just be written as a division calculation. And I ended up putting a poll up on Twitter to ask about it to get the general consensus. And what my belief was already was that a fraction has to have a whole number as a numerator and a denominator. However, we can still write something in that style. It just wouldn't be called a fraction. And that's something that I think it was really beneficial to even speak to the pupils about when we're talking about equivalent fractions. This is just a quick one that I also did with the class, asking as an open-ended task, asking pupils to show me fractions that were less than 1, equal to 1, and more than 1. Fraction calculations is what I asked for. And the kind of entry level of this was pupils who were doing things like 1/5 add 1/5 add 1/5 add 1/5 is equal to 4/5. And then their next one would be 5/5 is equal to 1, and the next one would be 6/5 is greater than 1. And that to me is absolutely fine within this second year class if that's what one of the pupils is doing. But then you had other pupils who were starting to use a range of denominators. They were using all sorts of different calculations, adding and subtracting. And then I had a pupil asking me, can you multiply fractions? Can you divide fractions? And it led on to, it ended up as a nice task because pupils were able to challenge themselves as much as they wanted. And I think there's a bit of a presumption before doing tasks like this that pupils might just be lazy about it. And I do differentiated starters quite a lot, where there's an option of questions to answer, and I did it a lot with this second year class. And my statement to them was, if you want to be lazy, go for it. If you want to do the easiest questions, on you go. That's fine. Just you take your easy questions and on you go. And what ends up happening is that they're doing their work. And for me, those are the sort of pupils that at times might be a little reluctant to engage in their work. But if they think they're getting to just do something easy, they'll do something easy. And before you know it, they're actually doing something a wee bit trickier and a wee bit harder again. And it's just been a really nice sort of task to engage that mixed ability class. I know I should say to my primary colleagues, I've even more respect for my primary colleagues now that I've left primary education. Working with mixed ability is a challenge. It's a huge challenge. And when secondary teachers, when I'm talking about that, it's coming from a point of I've had the ability class and then changed back to mixed ability. So tasks like these, open-ended tasks, are, I wish I knew more about these when I was teaching maths in primary. I'll put it that way. Okay, so this last one here on the topic of equivalence, basically because we have things that are not equal to each other. So in this section, I've kind of looked at bar modelling a bit, and fraction tiles would be the two main ones that I would look at. In terms of pizzas and round fractions, there's definitely a place for them, but it's very hard to compare the size of them to each other unless you have them physically and you can put them on top of each other to see that difference in size. But one of the things that I would use all the time in terms of fractions is number lines. And I think it's something that sometimes we associate with primary school. I don't think it's as commonly just associated with primary now. I think a lot of secondary colleagues are using number lines. Personally, I use them all the time in my teaching. Instead of saying to a pupil, well, imagine you're here and then add on this, or you're doing this to it, or whatever, drawing the number line is a really easy way for me to show my thinking and show where I think their thinking should be, or for them to show me what they're trying to explain, basically. So a question like, which is larger, 4/5 or 7/8 of 1? If you start looking at this with the mindset of equivalence and create two equivalent fractions here, you're making it into a much more difficult question than it has to be. This is a sort of question that pupils, as soon as if they have properly learned about equivalence, they should be able to answer this question. If they have not learned about equivalence and they've learned a set of routines, or they've just been exposed to certain types of equivalent fractions, then they're not going to be able to approach this in the same way. Using a number line and recognising where fractions go in the number line can really help with a question like this. So 4/5 or 7/8, which is larger? If we think about 4/5, it is 1/5 away from 1. So 4/5 would sit, that's obviously not to scale. It's actually wildly off scale there, but I had to do this, I could fit it all in the page. So obviously not done to scale, but 4/5 of 1, if that's at around there in the number line, then 7/8 of 1 would have to sit here because it is 1/7. So it is 7/8 is closer to 1 on the number line, therefore it is larger. So then we have this idea of, well, what about 4/5 or 7/8 of 2? Which one is larger? And hopefully then you can get pupils thinking a wee bit more about this. I'm just going to skip through this part because I can show you there. 7/8 of 2 is the way I've written it there, as opposed to what the actual number is. What if I asked you 4/5 or 7/8 of 1/2? And that now looks like a really difficult question. But if you understand fractions and you just put 0 and 1/2 on a number line, you can plot those 2 points and where they would be in relation to each other. And then we can look at 4/5 or 7/8 of x. And then if you want to take it further, list possible values of x and y. Now, if we were in real life in Stirling, I would be asking you to sit and work through this for a wee while. If you want to work through it, you can take a photograph of it and try it later on. I came up with this the other day and thought, oh, that looks quite good, and then sat and did it, and it just got me thinking a wee bit more about what numbers would fit here and what the conditions have to be for that to be true, and at what stage we can, well, basically what started going through my head was, what stage can we make these equal? And this is certainly not a task that I would suddenly throw on to a group of first year pupils when they're first joining me in secondary school, but it's just a sort of extension task that you could use with pupils to develop a deeper understanding of fractions. So I'm going to have a wee look now at mixed numbers. And the reason this part of fractions is in my head is because this is one of the topics that I'm teaching right now to my first year class. We're looking at, sorry, we're not looking at mixed numbers. We're looking at adding and subtracting fractions from whole numbers. So we're looking at things like 4 subtract 1/3. But we're not looking at mixed numbers until another topic. And that then in my head, I thought that there's a, how can we possibly do that? So I looked at mixed numbers as a thing on its own without thinking about it in terms of improper fractions. And usually I would only be thinking about them in conjunction with each other. So the first way that I looked at mixed numbers is by using a bar model. And I actually did this with using the MathSpot website. So we had a bit of a representation of it from there, but for pupils weren't able to do that because it was online that we were learning this. Questions like this, if you're trying to still do this with fraction tiles, you need loads of them. If you're not lucky enough to have fraction tiles in your school, I would be amazed and very jealous if you had enough for each child to have a full set of fraction tiles. And if you've got one full set of fraction tiles, you've only got one. So you have to be a wee bit more inventive with this. But I would hope by the time of doing this that pupils have had experience of working with fraction tiles and an understanding that comes from that. And perhaps the fraction tiles are not required for this. It depends what way around you do it. So the bar model is a resource that is very well thought of, and I absolutely agree with it. The reason I like using the bar model is because I can compare it directly to what the concrete resource looks like. So when we talk about concrete, pictorial and abstract, if you use a pictorial representation like a bar model and pupils have never been exposed to what these fractions look like in real life, it can be an abstract concept for them. So it's important to say that just because we've got something that is pictorial doesn't mean that it's not abstract in the pupil's understanding. I hope that makes sense. So I would encourage using the tiles first so that they can see in a different way before they start drawing it themselves. So 1 add on 1/5, the way we spoke about this was, well, I've got one whole and I've not got quite another one whole left. So 1 and 1/5 would look like this. Now that may seem very obvious, but one of the things that I was really keen to share here with pupils is how that then looks on a number line. And what we can do is directly relate it to a number line underneath here. So here's the number 1 because there's a journey of 1 that's happened by the time we get to the end of that number 1 bar model. That bar, sorry, it has a value of 1, so the distance there is 1. So the distance of the next one is 2. And matching this up directly with the bar model so that at one stage I'm hoping to move on to, or I now have with that class, we've moved on to just showing it on a number line. And representing where 1 and 1/5 would be so that they can see why it's sitting there, and yeah, hopefully just increase their understanding of it. When I moved on to a question like 3 and 1/5, I didn't ask pupils to draw out 3 individual bars because what I want them to get this understanding of is that it doesn't matter what the whole number is. When we add on 1/5, we're looking between 2 whole numbers now. So 3 and 1/5. Oh, who's going to spot my typo? Oh, I've hidden it quick enough, I think. 3 and 1/5, I drew it like this, where it was kind of off the screen. And we were just imagining that there was 3 there. The rest of the 3 is somewhere off the screen. So we've got 3 and 1/5. And in a number line, we've got that is between 3. Oh, there's another mistake. It's between 3 and 4. So we should have 3 and 1/5 in there. Then we moved on to things like 3 and 2 and 1/5. And when we get to here, this is where I would not be using a bar model anymore. If I still need to use a bar model, I go back and do those sort of questions again where we're using bar models. I don't just decide that because I've done that part and I want to move on to here, it has to be about pupil understanding. So one of the things here is when using a number line, the way of drawing a number line that pupils that I'm working with and that I have worked with in the past quite often draw it in jumps. And jumps, absolutely, that's what the word that has been used a lot, of jumping along a number line, and you count the number of jumps. But in secondary school, since I've started teaching in secondary school, I prefer to use a directed number approach. So when we're saying that we're adding on 2, it's positive 2. And if you can get pupils into this habit of showing the direction that they're going in, this is us starting to work towards vectors and an understanding of vectors as having direction. So the direction of this is important. We're taking 2 steps to the right. It's not just a jump of 2, because a jump could go forward or back. We've got that arrow in there to show us the direction as well. It's also a lot neater in the drawers when it's a straight line. That's a wee personal line for me. So if we add on 2, we get to 5, and then we add on 1/5. We've not gone as far as 6. And I'm really clear with pupils that we have to show where 6 is, because otherwise we can get mixed up as to what this number is going to be. With adding, it's not as common, but I'll show you then when it comes to subtraction, this is worthwhile. So we've got 3 add 2 add 1/5 is 5 and 1/5. And then we go on to the questions that pupils do tend to struggle with. And I would argue that the reason they struggle is because they don't understand it. They are trying to do a process, or they're trying to go through something that there's a bit of understanding that's missed. 7 subtract 1 and 1/3. 7 subtract 1 is nice and easy, and I'm saying that we're adding on -1. Now, that depends where it falls within your topics, if you've taught negative numbers or not. I would argue that, not argue, it's a bit strong. I would suggest that we talk about negative numbers, or we should be talking about negative numbers in primary. If we look at the experiences and outcomes, we're talking about negative numbers on a number line. We're not doing calculations with them, but we're just talking about numbers on a number line. So in this question here, I can say 7 is getting more negative, is becoming more negative by 1. And then the number before that is 6. And if we become more negative than that, have we gone as far as 5? No. And that's why we've got an answer of 5 and 2/3. The number of times I've asked pupils a question like this and they end up with an answer of 5 and 1/3 or 6 and 2/3, they've got themselves completely muddled up in where they are on a number line. And by just putting these numbers on the number line, they can then see a bit clearer. So then we can go on to things like, what number could this be? What number could this be? What number does this have to be? So when I've got them and it's an equal spacing apart, then we know what the number actually is. Whereas in questions like this one, I'm saying, what could the number be? Because we can't see it exactly. What about this one? What could the number be? And that's not a fraction there, but it could be. I could have had the number -3 and 1/4. And there are obviously so many numbers that it could be. And if I've been talking about fractions with a class and I put a question like this up, you can guarantee that quite a few of them will put a fraction, a mixed number as their answer. So this wee task here is one that I've shared before. And I said, which of these statements could be true? But I'm actually going to just jump on from this because we are very short on time. Spent too long talking about this part. Just with regards to number lines, just a wee recommendation if you've not been on Don Stewart's website already. So there are loads of number line tasks on here and ideas. And I suppose that these sort of ideas are what helps me realise the possibilities with number lines, I would say. The number of all the different ways that you can use number lines throughout secondary school. With improper fractions, this ties in with number lines as well, but thinking about number patterns is really important in fractions. So 1/8, 2/8, 3/8, 4/8, 5/8, and obviously 6/8, 7/8. When I give a pattern like this, I'm looking for pupils to tell me what comes next, and then tell me what the, oh, thanks, Bryn, I'll put that number line website in a wee minute. Tell me what comes next, and then tell me what are we adding on each time. And in a question like that, so many times you have pupils saying we're adding on 1. And even that in itself is a misconception. We're adding on 1 is not correct. We're adding on 1/8. So recognising what the jump is there as 1/8 is just another kind of talking point, I suppose. And then really important to go over 5/5. You can have 6/5, you can have 7/5, and sometimes people think that's not allowed, or someone else will say, no, you have to say 1 1/5, and that's a different way of writing it, but both are accepted. In National 5 Maths, you're allowed to write it either way. And then jumping up at 2/9 at a time. And in primary school, we do a lot of counting, but usually in whole numbers, and it's worthwhile to count in fractions as well. And then this last one here, which you can see we're starting to consider going into negative fractions. So going from a mixed number to an improper fraction, using the bar model, we can split up 2 1/5 into 15/5 and write that as 5/5 add 5/5 add 1/5. Not 15/5, 11/5. And then we can count that up as 11/5, adding together the fractions with a common denominator. If it was 11/4, same idea. Sorry, I'm flying through this part now because I want to go on to something a wee bit more interesting just for the last 2 minutes. So something like 16/6, if I was asking pupils what that is as a mixed number, I would expect them straight away to simplify it. Don't make this any harder on yourself than it has to be. That's something we should simplify straight away to 8/3. And then we can write it out as 2 2/3. So this is, I think, going to be the last thing that I have a chance to speak about. Yeah. In terms of division. So that question could have started off as, what is 16 divided by 6? And I've been encouraging pupils, I'm trying to just get rid of the division sign when it comes to my maths teaching. I'm joking there, obviously division sign comes in different calculations, they have to know what it is, they have to know what it does, but I would encourage pupils as soon as possible to rewrite these questions as fractions, because when you do that, you can simplify it. And when we come to a question like 156 divided by 14, we can write that as a fraction, 156 out of 14, 156 14ths, etc. So if I was trying to change this fraction into a mixed number, which is basically what I'm trying to do when I do this division calculation, I can say, well, 156, what number can I get quite close to that I know that's an easy number that's in the 14 times table, or that is a multiple of 14. And I would jump here to 140 as my first one, because I know that answer is going to be 10. So this links into the ideas of area models, etc. But the area model, using it for a number like this, to me is a bit ridiculous. If you were doing that with the concrete resources, you've got loads of them. If you get the understanding with smaller numbers, then you don't need to keep using them for the larger numbers. And if a pupil's at this stage and they need to get the concrete resources out to understand how to do division, they shouldn't be doing questions like this. They should be doing simpler questions that are more appropriate for using concrete resources. 140 14ths add 16 14ths. We can then rewrite that 140 as 140 over 14, 14 over 14, and 2 over 14. And we get to 10, add 1/7 when we simplify them. But what I think gets missed a lot in division is simplifying a division calculation. I mentioned it just before, and some of you may have predicted that's what I was going to say next. 156 out of 14, that should be simplified before we start that division calculation. And this is something I never thought about until the last couple of years, simplifying my division calculations. So if I simplify that, they're both even numbers. We've got a common factor of 2. I can simplify it to 78 divided by 7. And now I've got a much easier division calculation to do. 78 divided by 7, 77 I've gone for. I could have gone for 77ths as 10. Add 7 sevenths as 1 7th. And then we get to an answer of 11 sevenths. So simplifying your fractions can help you with doing much more difficult division calculations. So I am very aware of the time here, and I've not moved on to the last part, which was fraction of an amount. Basically what I was going to do was things like this. 1/4 of 8, 3/4 of 8, and then moving on to, we should still be doing things like 5/4 of 8. And that was pretty much it. So I'm going to finish off there and ask that if there are any questions that anyone has that they would like to put in, and to just say thank you very much for coming. Thank you very much for staying to the end. And please let me know. Twitter's probably the easiest way to get in touch with me if there's anything that you're wanting to speak about any further. So if anyone has any questions for the last minute and a half, you're welcome to stay on and ask them. Thank you.
Great stuff. Thank you so much, Roisin. That was really, really interesting. David's giving you a round of applause there.
Thank you.
So's Kirsten. Thank you, Kirsten. A couple of things that have sort of come to mind just listening to what you had. I've taken loads of notes. I've taken lots of screenshots as well. Hope that's okay.
Of course, yeah.
But a couple of things that sort of stood out for me is I don't think we can underestimate what we have to, you know, the modelling and the bar modelling and all of the different concrete materials that, you know, it's so important that we do use. But something, you know, just one of the last things that you said there was that if young people aren't able to do slightly bigger numbers without concrete materials, then you need to take a step back. And sometimes I think we're a bit more conscious about moving things on potentially too, maybe not quickly, but there's this impetus that we need to get through things, both in primary and secondary. Didn't used to be the case in primary, but it's
very much
that way. Yeah, becoming that way big time.
When I taught in primary, and I was one of, there was 4 primary 2 classes, and when I speak to my secondary colleagues, they say things like, but there's not the time pressure. And I said, I would be sitting in a planning meeting and my 3 colleagues, they were on to page 17 in the workbook, but I was only on page 14. Mm-hmm. And there still was at that stage. It doesn't seem to, there's a lot of authorities that are doing a lot of work to get away from that, which is brilliant. Mm-hmm. But certainly I've just seen a question here. Can I ask if progression pathways are common? So one of the things in the progression pathways that I saw in one authority is that idea of adding fractions with common denominators, and it comes in a lot later than it should. So there's progression pathways that are excellent in a lot of authorities. Some only go as far as second level. And in some authorities, the secondary teachers have not adopted them in the same way as primary teachers. That's my understanding anyway. The progression pathways, there's a lot of really, really good work in them and really clear instructions, like is mentioned there. But even within that, I think even if you look at something on a progression pathway, it doesn't mean that you necessarily know how to explain it and know how to show it. When they say to use bar models, if you use bar models but they don't understand fraction tiles, you've kind of missed something out there. Yeah, that's my kind of understanding in terms of that, I think.
Great. No, that's
this one.
Yeah, Angus have quite a wide range of materials, mainly I think sort of due to they tend to get things going quite quickly, but I know that Glasgow are doing a significant amount of work in and around, you know, numeracy and mathematics as a significant result of Maureen McKenna being at the forefront and leading the way. So yeah, great stuff. Absolutely fantastic. Thank you so much, Roisin. Really, really appreciate that today. If anybody else has got any other questions, then please do pop them in the box. If not, off you pop to your next I think it's the discussions next, if I'm correct in remembering. There's no discussions in this room, so you'll definitely have to leave. But thank you again, Roisin. Really appreciate your time. Really fantastic that you've been able to share what you've been doing in your own practice with us today.
Thank you very much.
So we've got a hand up there from Ailey Clark.
Ailey, do you want to come in?
Hi, sorry.
Hello.
I had a quick question regarding, you sort of touched on directed numbers and your number line. And I don't know, I just wanted to ask if with you, when you're doing concrete, pictorial and abstract, have you used algebra tiles for directed number? And then do you link that to the number line? And have you had any sort of crossover or issues, or does it all link very nicely?
Yeah, I have. I wish I had it open right now. I've got a picture of a number line with the positive integers, so like 1, 2, 3, 4, 5, 6, 7, etc. And then when it goes into the negative numbers, having it as the red, and actually using like coordinate axis for that, for showing the positive and the negative, and you can show things quite clearly on that. So I do use algebra tiles. That's the way that I choose to teach it. However, at the start, I was only using algebra tiles, and I actually feel like I had it in my head that algebra tiles were the way to go and not number lines, and that number lines caused too much confusion in terms of negative numbers. And actually, I found that I had gone too far away from number lines, that the algebra tiles in themselves became quite an abstract idea for pupils. And it was only by putting that together with the number lines that you see pupils really understanding it. And the algebra tiles, an empty number line, now pupils, if they're doing something like 43 add on negative 27, I would never expect them to draw out 43 positives and 27 negatives, but I would expect them to draw an empty number line. If they just know the answer, that's fine. But if they're doing an empty number line and literally just what direction am I going in, and I've got pupils in National 5 that keep making mistakes with negative numbers because they haven't had that experience in early secondary. And those pupils, I'm saying to them, see in National 5, see if you have to draw a number line on your exam paper, that's fine. If it gets you to the right number and just that arrow of what direction am I going in. So yeah, I'm absolutely an advocate for the algebra tiles. And that's where I think the language of becoming more negative, I'm still not convinced that's the right thing to be saying, but becoming more negative and becoming more positive on a number line, you can show that quite clearly. Hope that answers it.
Thank you. Yeah, it definitely does.
No problem.
Great. Fantastic. Thank you.